Hello everyone. Welcome back to our cybersecurity operations series. In today's session, we are covering one of the most important topics in the entire field of cybersecurity. That is Security Operations Center or SOC and the tools that power it called SIEM systems. By the end of this lecture, we will understand exactly how a company watches over its digital systems 24 hours a day. Who does that watching and what tools like Splunk and the ELK stack they use to do it. This is a hands-on lecture. Along the way, I'll be showing you some live demos so you can see these concepts working in the real world. Let's get started. Here's our roadmap for today. We are going to split this lecture into two parts. The part one is all about the security operations center itself, how it is structured, who works there, what security monitoring actually means, and a first look at SIEM. Part 2 goes deeper into SIEM and log management, where we will get hands on with two of the most popular tools in the industry, like Splunk and the ELK stack. We'll also cover two critical skills every SOC analyst needs, like log correlation and alert management. And remember, we have live demos too. So let's go further. Let's start with the basics. What is a SOC? That is Security Operations Center. A Security Operations Center is a centralized team and often a physical or virtual control room whose entire job is to continuously monitor, detect, analyze, and respond to cybersecurity threats across an organization's systems, networks, and data. Here's the analogy that will help this take. Let's think of a SOC like a hospital's emergency room, but for computer networks. Just like an ER is staffed 24 by 7 and constantly watches a patient's vital signs, heart rate, blood pressure, oxygen levels, a SOC watches the vital signs of a company's IT systems. That is, login attempts, network traffic, file access, and more. The moment something looks abnormal, the SOC team jumps into action, just like doctors would if a patient's heart rate suddenly spiked. The SOC has three core objectives. First, detect threats early. That is, the earlier a threat is caught, the less damage it causes. Second, respond quickly. That is, speed matters anonymously in security. Minutes can be difference, but a contained incident can, and a full-blown breach. Third, maintain continuous visibility. 24 hours a day, 7 days a week, 365 days a year. Attackers don't take weekends off, so neither can a SOC. You will notice the three icons on the right side of the slide, that is detect, analyze, and respond, connected in a loop. That's intentional. This isn't a process you do once and finished. It's a continuous cycle that never stops running. Now, can you think of a real world system other than a hospital that works this same way? Like always watching and always ready to respond? Can you? Yes, it can be air traffic control or maybe bank's fraud detection team. Yes, let's go to the next slide. Now that we know what a SOC does, let's look at how it is organized internally. Most SOCs use what's called a tiered model. Think of it like levels in a video game, where each level requires more skill and handles tougher challenges. Tier 1, the triage analyst. This is the front line. Tier 1 analysts watch the incoming stream of alerts, do the first check to see if something looks suspicious, and either close it out if it's harmless or escalate it upward if it looks real. Tier 1 handles the highest volumes of alerts. That's why it's widest bar in our pyramid. Tier 2, the incident responder. When something is escalated from Tier 1, it lands here. Tier 2 analysts dig deeper. They investigate the scope of the problem, figure out what systems are affected, and begin containing the threat so it doesn't spread further. Tier 3, the threat hunter or team lead. This is the most senior level. Tier 3 handles the most complex incidents, proactively hunts for threats that automated tools might have missed, and fine tunes the detection rules so future attacks get caught faster. Why does this tiered structure matter? Have you ever thought? Yes. Imagine if every single alert, even the small, harmless ones, went straight to your most senior, most expensive expert. That expert would be buried in noise and would never have time for the truly dangerous complex attacks. The tiered model protects your best talent for your hardest problems, while still making sure every alert gets looked at by someone. Escalation always flows upwards, that is, tier 1 to tier 2, tier 2 to tier 3. It never skips a level unless it's a critical emergency. Getting roles and responsibilities. Let's zoom in even further and meet the actual people who work inside a SOC. This builds directly on the tier structure we just covered. First, SOC analyst, that is tier 1. They live inside the SIEM dashboard. Their day to day job is watching for alerts, doing the first triage, closing out false alarms, and escalating anything that looks like a real threat. Second, incident responder, tier 2. When an alert is confirmed as real, this is the person who takes over. They investigate the root cause. How did the attacker get in? And then contain and remediate the issue. And then remediate the issue. Third, threat hunter, that is tier 3. This role is proactive, not reactive. Instead of waiting for an alert, threat hunters go looking for signs of attackers who may have slipped past automated defenses entirely. Fourth, SOC manager. Think of this as the team captain. They oversee daily operations, manage the analysts, and report the key metrics like how many incidents were handled and how quickly you are up to company leadership. Security engineer. This is the builder. They design and maintain the actual tools the SOC relies on, the SIEM platform, firewalls, and detection rules. Sixth, threat intelligence analyst. This person tracks what's happening in the wider world of cybercrime, new attacker techniques, new malware, emerging trends, and feeds that knowledge back to the team so they know what to watch for. Let's take an example. Imagine A phishing email slips through and an employee clicks a malicious link. The SOC analyst noticed unusual login activity and flags it. The incident responder confirms the account was compromised and looks in and locks it down. The threat hunter checks if the same attacker touched any other accounts. The security engineer later builds a new detection rule so this exact phishing pattern is caught automatically next time. The SOC manager reports the full incident timeline to leadership. That's a real SOC team working together, tier by tier, role by role. Let's move further. Security monitoring. Now, let's talk about the engine that drives everything a SOC does. Security monitoring. Security monitoring is the ongoing process of collecting and reviewing data from across the entire IT environment. That is, to spot signs of malicious activity before they turn into a full breach. What actually gets monitored? Network traffic through firewalls and intrusion detection prevention systems, that is IDS or IPS, endpoints, laptops, desktops, servers. Third, applications and databases. Fourth, cloud services and identity systems. Fifth, user authentication and login activity. Here's an analogy. See, security monitoring is like a bank's combination of CCTV cameras and alarm sensors. The cameras, which represent your logs, record absolutely everything, all the time, whether anything interesting happens or not. The sensors, which represent your detection rules, only trigger an alarm or an alert when something unusual happens. For example, a login attempt from a brand new country at 3 a.m. would trip that alarm immediately. There are three types of monitoring you should know. The first one is real time monitoring. It alert appears the instant something happens. Second, periodic monitoring. Scheduled reviews and audits done on a regular cadence rather than instantly. Third, behavioral monitoring. This looks for deviations from normal patterns. For example, if an employee normally logs in from Mumbai during business hours and suddenly there is a login from another country at midnight, that's a behavioral red flag, even if no specific bad signature was detected. Here, there is something important to remember. Monitoring is continuous, so it is never a one time check. The moment you stop watching is exactly the moment something can slip through. Now, let me ask you something. Why do you think behavioral monitoring is becoming more important as attackers get smarter? Just think over it. It is because attackers now often use stolen but valid credentials. So there's no obvious broken law. It's only unusual behavior gives it away. Okay, so now let's go further. Now it's time for our first live demo. I am going to switch over to a sample SOC monitoring dashboard so you can see exactly what an analyst look at during a normal shift. In this demo, we will walk through a simple SOC monitoring dashboard, look at how raw events get turned into visual alerts, point out severity levels, timestamps, and source IP addresses. Walk through how an analyst would triage one live alert step by step. Let's go. So this is the SOC monitoring dashboard. Uh, so here are some KPIs, that is key performance indicators, that are events ingested, open alerts, critical alerts, and average time to triage. Yes, these are the severity color codes, like red for critical, amber for high, cyan for medium, and gray for low. Let's just click on this possible account takeover and see what happens. When we click here, we get something over here return. Okay, like see, I'll show you. This changes, keeps changing. Okay, let's click again. So when you click on any objects, the panel expands to show the raw correlated log lines, that is like failed login, firewall block, new IP login, large download. This is your log correlation payoff moment. Okay, now let's see. Let's click on this possible mark as investigating. This is the event volume. These are the top alert sources. Now let's get back to our slide. Okay, so this has been created using HTML. In actual also, you can just see this really by signing up for the free Splunk enterprise trial. You can install it locally and can load their free boss of the SOC sample dataset that is built specifically for security training, and via settings. Then you can add your data. Then you can run the Elasticsearch via Docker, use Kibana's built-in sample datasets, or install Elasticsecuritys free tier, which ships the pre-built detection alerts. And in this way, you can perform. Okay. Now let's get back to our PPT. Yes. As you just saw, a dashboard turns thousands of raw logs into something a human can actually act on quickly. That visual triage is exactly what SIM tools are built to do. And that brings us to our next topic, SIEM. We have mentioned SIEM a few times already. Now let's properly define it. Yes? SIEM stands for Security Information and Event Management. It's a platform that collects logs from every system across an organization. It stores them centrally and helps analysts search, correlate, and generate alerts on that data. Why do we actually need a SIEM? Here's a number to think about. Say a mid-sized company can generate millions of logs lines per day from servers, firewalls, applications, and many. Yes? So there is simply no way a human being or even a whole team of humans could read all of that manually, right? As SIM does the heavy lifting, that is, it aggregates everything into one place, indexes it so it's searchable, and automatically flags the event that actually matters. Yes, this is what SIM is. The core SIM workflow has four steps. The As shown in the diagram, it is collect, correlate, alert, and report. What will be it collecting? It will be gathering logs from every source. What would it be doing in correlate? Yes, it will be connected related events. We will go deep on this later on. Okay. Then alert. It notify analysts when something suspicious is found. Report. It summarizes activity for compliance, audits, and leadership. Let's understand with an example. Imagine 500 security guards each writing in their own separate notebook all day long. SIM is the control room that collects every single notebook, cross checks the entries against each other, and only rings a bell when something suspicious lines up across multiple notebooks at once. Some of those most popular SIM tools in the industry today are Splunk, IBM QRadar, Microsoft Sentinel, ELK or Elastic SIM, and ArcSight. In part 2 of this lecture, we are going to focus on two of the biggest ones, that is Splunk and ELK. Let's wrap up to part 1. We now understand what a SOC is, how it's structured, who works in it, what security monitoring means, and what a SIEM is at a high level. Now, in part 2, we are going to roll up our sleeves and get into the actual tools, that is Splunk and ELK stack, log correlation, and alert management. This is where things get hands on. Let's go further. Let's start with Splunk, one of the most widely used commercial SIM platforms in the world. Splunk ingests machine data, meaning logs, and lets analysts search, visualize, and set alerts on that data using its own query language called SPL, that is Search Processing Language. Yes, Splunk has three major components. The first one is forwarder that collects and sends log data. This sits on the source system. Second, indexer. This stores and indexes the incoming data so it's fast to search later. Third, search head. This is the interface where analysts actually log in and run their searches. The key concepts are you need to know are the first one is index. Think of this as a labeled container or folder that holds a set of log events. Second, source type. This describes the format or label of the incoming data. For example, firewall logs versus web server logs. SPL, Splunk's own search language, similar in spirit to writing a database query, but built specifically for searching log data. Now let's look at a real SQL query as shown. Index equals to security, source type equals to auth, failed login, stats count by user, as source IP, sort count. Let's break this down piece by piece like reading a sentence. Index equals to security, source type equals to auth, failed login. This tells Splunk search only inside the security index, only look at authentication logs, and only find lines that contain the face failed login. Next, stats count by user, source I input, source I. The pipe symbol means take the previous results and do something more with them. Here we are counting how many failed logins happened, grouped by each user and each source IP address. Sort count finally sorts the results so the highest counts appear first. Now, why does this matter? If one user from one IP address has 200 failed login attempts in the last hour, that's a very likely a brute force attack. Someone trying to guess a password over and over. This one simple query instantly surfaces that pattern out of potentially millions of logins. Some of the common use cases are: first, searching for the failed login attempts. Second, building dashboards for daily monitoring. Third, setting up real-time alerts. Let's go further. So it's time for our second demo. Let's actually go into Splunk and run a search ourselves. In this demo, we will log into the Splunk search interface, run a basic SPL search on sample log data, use the command to summarize the results, and turn that search into a simple dashboard panel. Come on, let's go. Let's actually run a search in Splunk. I already have a query loaded here. Let's see it together. Its index equals to security, security type auth, failed login, stats count by user, SRC IP sort count. This tells Splunk search the security index only looks at auth logs, find failed logins, then count them grouped by user and source IP, sorted highest first. This is called the meta row. It shows 3214 events matched in 0.42 seconds. Splunk just searched through 1,000 of events in under half a second. This is our events over time histogram. This bar chart shows event volume across the day. Notice the spike here. That's worth investigating on its own. Now, this is the statistics table. This row mentions the user is r.meta, its source IP address, and is visually flagged in red with an investigate badge. And here's our answer. R.meta had five failed login attempts from the same IP address. That's a strong signal of a brute force attempt. Yes. Now let's go to visualization. Splunk can turn that same result into a chart with one click, useful for spotting patterns visually instead of reading rows. Now let's click this firewall blocks by source IP. Now this is our new search. Notice the query bar updates instantly and so does the results set. Let it load. So this is our new histogram. Okay, let's just click on Save Dashboard panel. And finally, once I have searched, I'll want to check regularly. I save it as a dashboard panel. So tomorrow I don't have to rewrite this query. Okay, that's the core Splunk workflow. Now, let's get back to our slide. Now, that's the core Splunk workflow in a nutshell. Search, summarize, and visualize. Everything else in Splunk builds on top of that basic pattern. Let's move further. the ELK stack. Now let's look at a very popular open source alternative to Splunk, that is the ELK stack. Many companies choose ELK because it's free to use and highly customizable. ELK is actually three tools working together, and the name is an acronym for each one. For E, it stands for Elasticsearch. This stores and indexes the log data, making it searchable in real time. Think of it as the engine and the warehouse combined. L, that is Logstash. This tool collects, filters, and transforms raw logs before they get sent into Elasticsearch. It's the preparation step, that is, cleaning and organizing the data. Next, K, Kibana. This is the visual dashboard layer. It takes all that indexed data sitting in Elasticsearch and turns it into charts, graphs, and tables that a human being can actually read and understand. Let's understand this with a example. Think of a newsroom. Logstash is the reporter out in the field gathering raw stories, that is our logs. Elasticsearch is the newspaper's archive department organizing and storing every story so it's instantly searchable later. Kibana is the actual printed newspaper layout, that is, the final visual product that readers, our analysts, and actually look at. Just like Splunk, data flows through ELK in a pipeline. Raw logs go into Logstash. Logstash cleans and forwards them to Elasticsearch, and Kibana sits on top to visualize everything. Let's go further. Let's see ELK in action. Okay, so in this demo, we will view sample logs that have already been indexed inside Elasticsearch. Explore Kibana dashboard built from that data. Filter logs by time range, source, and severity. Create a simpler bar chart showing event color counts. Now let's go to see the demo. Now let's look at the same kind of the data but through the ELK stack, specifically Kibana's interface. So this is the document list. Okay. This is Kibana's Discover view. Every row here is one raw, indexed log event, timestamp, severity, source, and message. This is what Elasticsearch has stored and Logstash prepared. So these are the severity passages. You can see critical, high, medium, and low. Each are of different colors. Red, amber, cyan, and gray. So just like our SIM dashboard earlier, colors tells us severity at a glance. Yes? Now just let's select this critical severity one. Let's select from severities critical. The document count turns to be 3. See. Now let's again select all severities. Now this was the filter for severities. Similarly, let's just write in the search box source auth. That is, it's narrow for further. It will search specifically within authentication source log. Okay, so now let's type it. All 7 documents are listed. Okay. Now let's just read the message. It is DLP alert. User is r.meta. Downloaded is storage is 812 MB file and new IP log. Yes. Now let's click the visual tab. Kibana's real strength is turning this raw data into visuals. Let's build a quick chart. Now you can see right now we are looking at event counts by severity, that is critical, high, medium, and low. You can see here medium and low are dominate dominating over here. Okay. Now let's use this breakdown events by this drop down over here. Now let's switch towards source. You can see auth, firewall, EDR, IAM, network, web, system, cloud, and applications. The documents are divided according to their source. Okay, now let's go to R of T. Documents are split into R's of T. Now you can see how this 20 events instantly reslice into a totally different view. First by source system and then by ROK. This is exactly the kind of pattern spotting Kibana dashboards are built for. Now let's get back to our slide. Now have you noticed how similar this feels to what we just did in Splunk? Collect, search, filter, visualize. Different tools, same underlying philosophy. Let's move further. Now we get one of the most powerful and most conceptually important ideas in this entire session, that is log correlation. Log correlation is the process of connecting related events from different sources to reveal a pattern that no single log would show on its own. Now, why does this matter so much? Think about it. Let's say one single failed login attempt by itself means almost nothing. People mistype their passwords all the time. But what if within the same 2 minutes window you saw a failed login, followed by a firewall block, followed by a successful login from a brand new IP address for the same user, and followed by a large file download? None of those 4 events alone is alarming, but together in that sequence, within that short time window, they tell a very clear story, a possible account takeover in progress. That's exactly what's shown in this timeline on screen. At 10 a.m., at 10:01 a.m., 5 logins failed from same IP. At 10:02 a.m., firewall blocks that IP. At 10:03 a.m., successful login from a new IP, same user. And at 10:04 a.m., large file download initiated. These 4 separate log entries that correlated together caused the SIM to fire an alert, possible account takeover. So there are 3 common correlation techniques. First, time-based correlation, that is, looking for events that happen within a specific time window of each other. Second, rule-based correlation, using explicit if X happens, then Y matters, written by security engineers. Third, statistical correlation, looking for unusual spikes in activity compared to an established baseline of normal behavior. Correlation is really what separates a basic log viewer from a true SIM. Any tool can show you individual logs, but a SIEM's real value is in connecting the dots automatically. At a speed and scale no human analyst could match manually. Um, Let me ask you, if you were designing a correlation rule to catch this exact account takeover pattern, what time window would you choose and why not make it too short or too long? Just think about it. Have a pause and think it. Well, let's understand this trade off. If the time is too short, you might miss slower attacks, and if it's too long, you may get too many false matches. Okay, let's move further. Every time a correlation rule fires, like the account takeover example we just discussed, it creates an alert. And that brings us to our final core topic, alert management, the discipline of handling alerts efficiently so that real threats never get buried under us. The alert lifecycle has four stages. First, generate. That is, the SIM rules fired based on correlated events. Second, triage. An analyst reviews the alert's severity and likely impact. Third, investigate. The analyst confirms whether this is a true positive, meaning it's real threat, or a false positive, meaning it looked suspicious but turned out to be harmless. Fourth, respond or close. If it's real, escalate and remediate. If it's for a false positive, document it and close it out. One of the biggest challenges in any SOC is something called alert fatigue. This happens when analysts are flooded with so many alerts, many of them minor or false, that they become numb to them and might miss a truly dangerous one hiding in the pipe. Here's how SOCs reduce alert fatigue. First, they prioritize alerts by severity. Critical, high, medium, and low. These are the severity categories. So analysts always know what to look at first. Second, tune detection rules regularly. Constantly refining rules cuts down on false positives over time. Third, use automated playbooks. For repetitive, well understood alert types, automation can handle the first response steps without waiting on a human. Let's understand it with a real life analogy, that is airport security alarms. If every single metal belt buckle triggered a full, in depth investigation, security lines would completely collapse. Nothing would ever move. Good alert management is like a well tuned airport scan. It flags real risks that need attention and lets harmless items pass through smoothly. So security staff can focus their energy exactly where it counts. Let's move further. So this is our final demo. Let's bring everything together. That is correlation and alert management by triaging one complete alert from start to finish. In this demo, we will open a live alert that was generated by a correlation rule, trace back the individual log events and triggered it, classify it as a true positive or a false positive, and document the response and properly close the alert. Let's switch to the demo. Now let's take one alert all the way through the full life cycle, that is generate, triage, investigate, and respond. This is the live alert queue. This alert already. Let's just choose one. Let's choose this unusual outbound data volume from ETL host. I'm just reading the description, okay? And the severity level is medium. Like this alert already fired. That is stage one. Generate is done. Now let's an analyst job to triage it. Okay. Now let's just click the row. I have clicked the row and we got this information, the expanded information. This is the expanded information. Now, stage two is triage that I'm reviewing severity and likely impact. It's marked medium, tied to a service account and not a human user. Now, this is our raw event trail box. Stage three is investigate. Now, I trace back to its actual log lines. Here's a 4.1 GB outbound transfer and look, the SIEM rule fired out equals to outbound volume anomaly and confidence is low. Re- now, now let's see this note for the analyst. It's confirmed schedule ETL export to partner S3 bucket closed as false positive. That's the investigation step in action. Someone checked, found a legitimate explanation, and documented it. Now, these are the three buttons where what we can use: mark as investigating, close as false positive, and escalate to tier two. Now, our stage four is to respond or close. Since this was already confirmed as scheduled, legitimate activity, the right move is to close it as a false positive, which is exactly what happened here. So we have closed it. Now let's search for another one. Let's take this high severity alert and click on it. Now, this one hasn't been closed yet. It's still marked as investigating. You can see. Yes. A real analyst would now be reaching out to the user directly to confirm whether they were traveling or whether this is a compromised account. So let's click on escalate to tier 2 because given the severity and the ambiguity here, I would escalate this to tier 2 for deeper investigation, exactly the tiered structure we covered earlier in the session. Now, let's get back to our session. Now, that's the complete life cycle from a raw log line all the way to a documented closure. This is exactly what a real SOC analyst does every single day, often dozens or hundreds of times per shift. Now let's move further. Let's quickly recap everything we have covered today. First, SOC. It is a 24 into 7 team structured in tiers, tier 1, 2, and 3, that detects, analyzes, and responds to threats. Roles: analysts, incident responders, threat hunters, security engineers, and managers each play a distinct important part. Third, monitoring. Its continuous visibility across network, endpoints, and cloud systems, never a one time check. Fourth, SIEM. It's a centralized logs from everywhere and helps analysts search, correlate, and alert at massive scale. Fifth, Splunk and ELK, two of the leading log analysis platforms, one commercial and the other open source, each following the same collect, search, visualize philosophy. Sixth, correlation and alerts. Connecting related events reveals patterns a single log never could, and disciplined alert management keeps that flood of alerts actually manageable. Together, these pieces are the foundation of how every modern organization defends itself against cyber threats around the clock. That brings us to the end of today's session on security operations centers and SIM fundamentals. I really hope this gave you a clear, practical picture of how a SOC actually works day to day and how tools like Splunk and the ELK stack turn an overwhelming flood of raw data into something a human analyst can act on quickly. If you have any questions, you can reach out us at biotechrewind@gmail.com. Thank you.